Components and projections. Consider two vectors u and v. And theta is the angle between the two vectors. The scalar component of v onto u is the dot product of u and v divided by the norm of u, which is the norm of v times the cosine of theta. It is also referred to as a scalar projection or an orthogonal component. In the figure, the scalar component is the length of the orthogonal projection of v onto u. In the first expression, the norm of the vector along which the projection is taken is in the denominator, while in the second expression, the norm of the vector whose projection is needed is the multiplier. Meanwhile, the vector projection of v onto u is the vector defined by the scalar component of v along u times the normalized vector u. The scalar component contains the magnitude information, while the normalized vector contains the direction information. It is also referred to as a vector component or an orthogonal projection. In the figure, the vector component is the orthogonal projection of v onto u, or it is the vector component of v that lies along u. This vector perpendicular to u is called the vector component of v orthogonal to u. It is equal to the vector difference between v and the vector projection of v onto u. In summary, the dot product of two vectors is important in computing components and projections. And they are related. The vector projection of v onto u is the scalar component of v along u times the unit vector in the direction of u, while the scalar component of v onto u is the length or norm of the vector projection of v onto u.